So far we discussed how to deal with data including arrays, strings, but now we can write a function or write not function, write set of lines, basically write programs, how to deal with this, how to manipulate these variables. So there will be 4 types, I will cover 4 types of programs. Okay. So the first simplest of them is called simple statements. So this is a set of statements. So each line which a type is a statement. So x equal to 5, y equal to x plus 5. So this is a statement. I could have put them in one file. I will show you one example. I mean, you can just put them in one file and run that file name. So maybe I should just run it once, just to give you. So you can put set of lines and all of them will run in one shot. So if I say print y, it will give you 10. So these are a set of lines. So these are simple statements. Each of them is simple statement. Now few key points which you need to know, that the variables get the data type. So every variable has a data type like float, integer or string from the data they store. Okay, it is not a strict typing in Python. Notice one more thing, that x is, what is the type of x here? Integer, and here is float. So I change the type of x, it has become float. It could also become an array. So C will not allow this, but Python will happily do this. So same variable can hold data of another type, like example given here. The variables are global. That means it can be accessed by any line or any set of program within that file. So this is useful as well as dangerous. So basically, especially variable. So don't, well, I am right now doing examples where I put x, y, a, b, but you should give name, specific names. Otherwise you may think that my value of x is something, but it was something else, because it was, sometimes say x is 3, then I say x equal to 5. So you should give, for example, temperature, must be temperature of today, or today's temperature, that is the name of the variable. Okay, and that will not mix with today's pressure. So pressure will be, I should not say x for temperature, y for pressure, you just write pressure. So variables are global and they have existence till the program quits, but you can delete a variable by this operation called del. So if you say del variable name, it will delete, it just goes away. We can also reset all the variables, means it will become all empty, no variable will be present, and you can use this function called reset, which will reset all the variables. Actually, if I using multiple files, which you will be doing later in the course, then variables from one file cannot be accessed by another file. Okay, you have to be careful. Yeah. Oh, anything. So this var can be integer. So oh, I mean all. So I wrote x equal to something, y equal to something, z, all that. I have a lot of variables. Now I want to start from scratch. Reset means just delete everything.
Is a keyword, final keyword?
No, please. Variables, for all variables. It resets all variables. No, I am not, this is nothing, don't worry about. So just a reset, just say reset, and it will reset everything. Means no variable will be there inside the memory. Okay, so this one has to be careful. Now we need another, the second class of statements are called branching statements. So everybody knows, I mean, if today is warm, then I should not wear sweater, and so this if then, right, I mean you need to take decision. So the statements look like this. So if condition colon, this is a very important, this colon. Without colon this will throw up error, and most of the time in the beginning everybody makes a mistake that colon is missing. So well, this program should work, but it is not working. So the colon is what this is more of a common error. Then you should put some blank. There are 4 blanks, not some, actually 4 blanks. So this is a tab. So this is called indentation. Otherwise Python will not understand what you have written. So this is, so if condition and else, between that it will execute set of lines. It need not be one line, it could be set of lines, and all the lines should be shifted by 4 spaces. this is called indentation, indent, shift it, and if you do not indent it, the code will not. So, this is one of the errors you will find start having in your first few homeworks. If you do not indent it, it is not going to work. Then put else and colon again, and then other statement, other set of statements. So, these are simple statements here, which actually it could also a branch. This can also so this is a set of statements. I will not say branch or something. So, it is set of statement. Or you could have, so this is one kind of conditional statement we may encounter. Else means anything other than the condition. But well, I say, well, if this condition is true, then I should do this, or some other condition is true, then do this. Then you can put another else if. So, ELIF is called else if, else if. Python has this is a syntax, ELIF, else if. So, I can continue and cover all of it. So, this is for branching statement. So, if, else, like that. So, one example, simple example is this. So, this is written in the interpreter itself. I did not create a file. So, if I do not create a file, so these are 4 blanks here. You can see this 1, 2, 3, 4, 4 blanks, you can see that. So, if x is divisible by 2, so a remainder of x, this is a remainder, no, remainder function, a remainder of x equal to 1, then odd, else print even. So, it will whatever x is there at that time in the program or in this memory, if x was not declared, it will throw up an error. So, suppose x is already known, x is 3, so it will tell you whether x is even or odd. Okay. So, this 4 lines will do the job, and answer is that x is 3 and it is odd. So, answer is written here. The print always gives you, it does not come with out, it just outputs in the first column. So, this is an example of a branching statement. So, this colon is important and this colon is important. Okay. You will encounter a lot of it. For example, I want to find a minimum number within a set of numbers. So, you will have to use if this condition. So, you have to write this function, how to find, the homework has all that, right, how to find minimum. So, the third class of repetitive statements, very useful, it is called loop. So, this example, so I have written a file called factorial while 5. So, I am going to run it after this. Okay. So, let us just first understand this whole thing is a file, inside a file it is written, set of simple statements, these 3, and this is a loop statement. So, let us understand what is this doing. So, n is 5. So, this variable n contains 5. So, I initiate or basically I create a variable fact, which is basically factorial, equal to 1, initialize it. My answer will be in fact. So, I create another variable I equal to 2. I do not want to say 1 because I want to multiply 2 onward. So, 2, 3, 4, 5 up to n, I just multiply in a loop. So, what will I do? So, till I, so I am going to increment I each time, and I will check whether I is less than n. So, this increment is happening here, and I check whether I is less than n, equal to n. If it is less than or equal to n, then multiply the factorial by its old value. So, it is getting, so we start with 1, then 2 multiplied by 1, 2 multiplied by 3, multiplied by 4. So, keep multiplying, is straightforward. So, this is getting so I am getting a product till n, and that is the answer once you reach n. And so, fact is a global variable, it is known till here. So, I say print factorial n. So, this is a print statement I am using, this is string, this is answer fact. So, this is a file, I want to run that file, what should I do? So, run the file name. The file name should have .py in the end, otherwise Python interpreter will not know what kind of file is it. And that is a good idea, you know, you have C functions or C files, C++ files, Fortran files. So, each of them should have unique name, and Python files have unique name .py, unique extension. So, .py means it is a Python file. So, answer is printed here once I run it. So, I will just show you this file because you need to know this for your class. So, this is a Python file, okay. Is created in some editor. So, that is why you need editor. So, the editor is up to you. If you use Mac, you can use Xcode. If you use something else, gedit is what is in Linux, which is convenient, very easy. This is a set of lines, exactly same what I have in the keynote. So, this indentation, this 4 is important, this 4 spaces here. If you do not have it, it is going to crash. You need to create this in editor. So, I go to that Python interpreter. So, I have to be in the right directory. So, that file should be in the same directory. Okay. Presently, I am not in the same directory. So, I can check whether which directory I am in. That is why you need to know this Unix commands. So, I need to know what directory I am in, pwd. So, this is not the right directory. So, this is in Python files. So, I can say ls, ls is the list. So, cd. It is not very clearly visible, but it is good for the recording, that is why I put the black screen. So, here this is the file, cd is chain directory. So, that file is here factorial while pi. Now, I can say run factorial while dot pi. Okay. So, you have to type it. So, this is called tab, if you know this tab will just do this. So, if I run it, I will get the answer. Okay. So, this is how you run a file. You create a file and run dot pi will work. There are more ways to do it, but just stick to one when we run file name. If I want to change to some other n, what should I do? I should just go to the file and instead of n I can just put 7, save it. So, I saved, okay, by some command. So, you must save it and then come back and run again. So, factor 7 is okay. So, you do not need to retype. If you had to type it, then it is like, I mean, it is not a good idea, you should type all of it again. So, save it in a file, just change n, it will work. Yeah. Yeah, you can do that precisely. So, if it is in file, then you can, so you can say input n, what I told you about input function, that is good idea, yes. So, you should input n, okay, that is another way to do it. Okay, so let us get back to our presentation. Is it clear how to get this work with files? So, this is for factorial using while loop, but there are several other loops. So, I like while and for. So, then it is called, so if I know the number of index, number of times I have to iterate, then I can use something called for loop. Okay, there is one more, I just wanted to say that this indentation is critical. So, this is called for loop, which is simpler than while. No? Suppose I know how many times I have to iterate, then just use for loop. If I do not know till what time I need to continue, then I should use while loop. For this example, is a trivial example, both are equivalent, but for testing minimum, rather to find a minimum value in an array, you do not need to go all the way till you find the, well, no, minimum you need to find, sorry. For minimum you have to go all the way, right, to find a minimum number, yeah.
It will not take the n plus 1.
No, it will not take n plus 1. 2 to n. That is a range function, no. So, what I had said, range is the wall, value of the wall, is not value of the element. So, the wall is at n plus 1, not the element. So, the range will go from 2 to n, sorry, the I will go from 2 to n, and this will work, right. So, so I is a local, well, I is a variable which will be in this range. So, I will be in fact in as a list, and list is, this is the list whose values are from 2 to n, and you multiply again. So, it is the same idea, instead of for loop I am using, instead of while loop I am using a for loop and print. So, if I run it again I will get the same answer. So, few things I would like to just remark here. Okay, so this I is a, I cannot use I outside. If I say after this, if I just write this and try to print I, will it print? I am confused now actually. This is, it will, so I will come. This no, then C it will not come, but yeah, here it will come. So, okay. So, ignore what I wanted to say. This I will, I believe will be 5 when it comes here. Yeah.
I will be not implemented. I will increment automatically or
I will increment automatically in for loop. You do not need to do it yourself. I will increment. Okay. So, when homework exercise is print I, see what you get. So, when do I use for and when do I use while? So, example I was trying to give, if I am trying to do find a minimum number in a list, then I have to check all the numbers. I say the first one is minimum, then see whether the second is smaller than the first. So, I have to go all the way. So, there for is good, but if I am searching for a number, then should I use for or while? As soon as I get the number, I should get out, I should not be doing it again after that. So, then while is good. Okay. So, you have to choose your loop properly. Now, next and slightly more complex structure is function. Okay. So, what all I have done? Simple statements, branching statements, repetitive statements. Now, I am going to do functions. Yeah.
I like want to check with an increment of 2. Shall I use it arrange line space or shall I increment I by 2 within the body?
So, range has 3 argument range. So, I can say 1, n plus 1 comma 2. So, it will increment by 2. So, range has 3 arguments, increment is of the third argument. Okay. So, function. So, suppose something has to be done again and again, like factorial or sine function. So, you do not want to write set of lines. In fact, you can encapsulate it, or rather you can make a box says this will always give me my desired result. So, sine factorial. So, it will come from that function in one line. Okay. So, you should know how to write a function. The example I said is factorial, it can be a function itself, or sine function, or minimum of an array. So, you should give array as an argument to this object, to the box, and you should just spit out this is a minimum. So, let us again write this factorial function. Now, I am going to write a function whose input is this n for what factorial you want, for which number, and I will give the number, I will give the answer. So, this is how you write a function. So, the first word is def. So, def is for definition. So, this is a definition of a function factorial. Okay. So, the name of the function is factorial and it takes an argument n. So, this is called argument. So, f of x is an argument. Now, within this I have this called fact equal to 1. So, this is a variable I create inside. So, this inside the function fact equal to 1, then I loop I goes from. So, it is the same for loop to range to n plus 1 and fact equal to fact star I and return fact. This is important. So, it will return a number. A function, of course, you would like it to return, but sometimes you do not want it to return. You just say, well, print something or do something and get out. So, but here I want it to give a value, and the value it should return is a factorial, and it is stored in fact. So, it will return this fact. Okay. So, this is a simple example for a function called factorial, and to call it is very easy. So, factorial. So, this is name of the function. I give a number 8. So, this is an integer, no? 8 it will give me a number. I want to say factorial something else, factorial 9, it gives me a number. Okay. So, this is very easy. In fact, we can. So, the homework has some things are you just do it write as a program, but then I wanted you to write like finding a minimum of an array. You can write as a loop, but then you write as a function as well. So, there are programs which may not be very clearly, my homework statement will not be very clear, but that is what I want. You should be able to write function as well as loop or statements.
Sir, except for function is compulsory for returning something?
Not necessary. It could do something inside, or print, for example, it will just print and return. Now, few important point. Suppose I say print fact, will it be visible? So, please imagine that this is I wrote in my interpreter and I ask for this fact, will it be visible? No, fact is not visible outside. So, that is a nice thing about function, it hides some variables it uses. So, fact is called local variable. So, we can run it actually, I can just show you that this is not going to work. So, this is also a file So, factorial function. So, this is a function I just had written. Now, I will run function dot pi. Okay, so it gives the answer, because it may remember fact from something else. So, reset. So, this is what I meant by reset everything. Now, I run factorial. Now, I say print fact, because fact is called local variable which is inside the function. So, it is not visible to the program. In fact, it is a good thing. Why should many variables should be available in the memory for the user? You can't, I mean, I can keep track of 5 things, not thousands of things. So, that is the idea. So, you want to hide them. So, factorial, these are called local variables. Okay. This is a standard thing in Python. So, these are local variables which are not visible outside. So, how do we pass argument? And it's important. In fact, every language has its own passing argument. Yeah.
So, the code you are, why it is only giving factorial for A? Why not general line? Because in the function it may not specified value for that.
So, no, the argument is in the whatever bracket, whatever you want factorial bracket, you put the value. Factorial 100 you want, put 100 there. It may become very large integer.
But say in the code you only give n, you have not specified the value for it.
No, I have not. So, definition, let's look at it. This is n is a variable.
But so when you run the code, you said run factorial underscore function dot pi, and you cannot give any value for that. When you run the code.
No, actually, no, here, okay. So, I get your point. Okay, so, okay. Yeah, so actually it was, okay, now I see what he is after. So, I should delete that, comment this line, factorial while. Inside the function I had 2 lines here below, that is what made. So, if I comment them, comment is by this hash, no? So, this comment, it is not going to run. Now, I should run again. So, it is nothing is coming. Now, factorial function is however there in my memory function. If I say factorial now 4 will come, answer will come. Okay. So, it runs it and it just gives you 24. Okay, so, let us quickly finish this aspect. So, passing argument. So, it has to be completely clear to you how are you passing the argument. So, in Python is passed by value, the integer and float or string is passed by value. So, what is pass by value means? It means something. It is a standard thing in programming languages in computer science. So, when you pass by value, the value of the variable is copied into the argument of the function. So, factorial n was there, n was the argument. So, when I say factorial 8 is copied there to n and you get an answer. But I could also have said factorial x and x had a value. So, let us say x was 8, x equal to 8 factorial bracket x, then you do something and you get out. So, will x be modified or not? What I passed. So, remember there are 2 things, one, so I will give you an example. Okay. So, what you pass is not changed, what you pass is not changed, that is called call by value. I just put the value and let it go. So, variable being passed remains unchanged. So, let us do an example. So, I do a multiplication function called mult a comma b. So, it has 2 arguments. So, but what you will get is, so this is another useful function, a star equal to b. What does it mean? This is equivalent to a equal to a star b. If my variable name is very large, then I save typing. Suppose it was pressure equal to pressure star b. So, I should have said pressure star equal to b. So, return a. So, it will return the modified a is modified and the value is a star b. So, now I have x equal to 3 as variable. Now, I say mult x comma 4. So, 3 goes here, multiply and the answer is 12, it returns 12. But what is the value of x after this? It remains as 3. Huh? It is not that x is copied here. Where is that? X is passed here, it is not passed here, x is copied there. So, this x does not mean this x really. Okay. So, you have to be, this x means I just copied this x into variable a inside this function. So, print x is 3. What about if I pass arrays? I could pass instead of a, in fact this function, this is a beauty of Python, you do not specify the type of the variable here. I could just pass array into this, a could be an array. So, but arrays are passed by references. What do I mean by this? So, array is not copied, the same array's address is passed. The first, so basically copying big arrays will be very expensive. Now, I may deal with 100 by 100 matrix, so 10 power 4 elements. Copying will be expensive for memory as well as computer time. So, arrays are not copied, neither in C, it is not copied in C. So, you pass that reference and it is going to be modified because I am basically pass the same array. So, you are not, that is not copying there, is passed by reference. So, I have an array A which is 1 comma 2. Now, I multiply this array, A is passed here as an argument, same function, mult function. So, what is the answer? So, multiply by 4. So, 4 into, so it is multiplying, so it is giving you 16. Did I copy something else? It should be multiplied by 4, so it should be 4 comma 8, no? I get the answer. But what's the value of a after this? So, actually it should be 2 comma 4, that's what. So, this is, it has modified, the array has been modified. It is unlike the last example where x was unchanged, here array is modified. So, this has to, you have to keep in mind when you use function. So, this is a very useful function, not useful for this course, interesting way to solve problem using recursivity. So, definition of factorial can be written like this, right. In fact, in math books you write like factorial equal to n into n minus 1 factorial. So, this is called recursion. You define a function using itself is very useful idea in nature, like fractals. Fractals are defined by itself. So, this is allowed in Python, this kind of function definition. So, I can define the same factorial function using this definition. So, it looks like this. So, definition factorial n will be, so this n into factorial n minus 1. However, if I just write this, it is going to go into infinite loop. So, how does it compute? How does it, in fact this will work, this Python it works. So, what is it, does it, if I want factorial 4, it goes here, it says 4 into factorial 3. So, it comes here and calls again, it calls the same function. So, factorial 3 will be, factorial 3 is equal to 3 into factorial 2, goes back, 2 is factorial 2 into factorial 1, 1 will be 1 into minus 1. So, it will go into infinite loop unless I close it. So, the closing is that when n equal to 1, I should return 1. So, as soon as it hits 1, it knows that bottom up. So, I should not go any more down and starts going back after that. So, basically go down till that n and then come back and start multiplying. Now, you know the answer, what is factorial 1, then you know factorial 2, factorial 3, factorial 4, answer is no. So, this is how it is going to execute. This is more expensive because you have to go down and go up. So, I was on this problem, Tower of Hanoi. So, how to solve this problem? So, everybody knows the problem. So, there are 3 pegs and each, well, the first one has a set of disks. Now, I have to transfer this disk from peg 1 to peg 3, but the rule is that smaller disk cannot be below the larger disk. Okay. So, how shall we do it? So, this is well known problem, yes. सबको छोड़ना पड़ेगा, सबसे छोटे को थर्ड में ले जाना चाहिए. So, I take, so my objective is to send it to third, huh? Okay. So, I take this, okay, so this one I do it here, I see. Okay. So you are getting it right, but if I want to tell the computer, so if you want to tell this to computer, how should I do it? I want to write a program. So if I write that many lines, so do this, so that's not a good program, right? So if I tell this full solution, it's not a good program. I mean, the computer is not doing in few lines. You should also write. So one objective of a code is that it should be short, as short as possible, and it should be efficient. It should take least amount of time. So I'll discuss that in a while about efficiency, but you have to do better than this. So you know how to do it better. I think Dinesh, you know how to do it. No? Okay, someone else? I have to put in the code. Well, I have sent you the file, so you should be able to see. I would say think recursively. Okay, this was not done in your ISCO course? No? Done? Oh. So the idea is, so basically I want to transfer everything here. So my objective is to write a function which will take n minus, so what I should do is, I should basically say, well, if I can push n minus 1 disk here, so this is n disks, always use n, it's general, don't say 3, 4. So idea is to take n minus 1 of these and push it to intermediate. So I have a function which can do it. Suppose you have the function, okay. So I send n minus 1 here, n minus 1 disks here, okay. The function which you have will do the job. Then the bottom one I sent here, the bottom one. Here, and then take this n minus 1 and put on top. Okay, so n minus 1 top. So I transferred everything. So if you know how to solve for n, then you also solve for n minus 1, and I can use it recursively. So the way you do for factorial. So compute factorial 4, I compute well, I suppose somebody gave me factorial 3, then I can always compute factorial 4. So that was the definition of recursion. So I am solving it recursively. So, and it's easy to code once you know the idea. So what shall we do? So it's there in the code. Python can do it easily, few lines. So these are code. So n is the number of disks. Source is you have to start from. I didn't want to put 1, 2, 3. That's again not a good choice of variables. You should choose a variable which will tell you, this is what you mean. Because I like my code to be used by other people as well, or myself. If you don't write a nice code, then you come after 1 week, you won't know what you have written. Okay, it happens to me. So if I write a code, what did I write? I can't figure out from what I have written. So you have to be careful what variables you choose. So source is a starting peg. 2, I want to say 2 for example will be here, and intermediate. So we have this as intermediate. If I don't have intermediate, I can't solve this problem. So what I say is, for if n equal to 1, if there is only one disk, it's like factorial. If it is n equal to 1, you say your answer is 1. If n equal to 1, then you just say from source. So I have to print transfer disk source to 2. So these are strings. So this is string and this string, and I send it there. For 1 it is trivial, right? I mean 1 you just do it. But suppose we had more than 1, then you follow the same thing which I told. Transfer n minus 1 from source to intermediate. So second argument is where you want to send, well, third argument. So this is the number of disks. The third argument, where you want to send. So don't send to 2, send to intermediate, n minus 1. So what I said, I take n minus 1 here first, that is the first step. So I take n minus 1 disk from source to intermediate, but 2 will be my intermediate for that process. Okay. For if I want to send n minus 1 here, I can use this as an intermediate. And then what do I do? So I have left with one disk. So let's transfer this disk to the from source to 2, from source to 2. And then, so I have this situation, n minus 1 sitting here and 1 sitting here, and after that I take n minus 1 from intermediate to 2, but this peg becomes an intermediate now. So source peg becomes intermediate for this process, and if you do this, you solve the problem. Okay, so this is called recursion. So if you know how to solve for n, you can solve for n minus 1. If you know how to solve for n minus 1, you can solve for n. You always have to stop somewhere, otherwise it will go to infinite loop. It will stop somewhere, otherwise it will keep calling and it won't quit. And once I run it, this is output, very similar. Well, this is what you will get after the computer has solved the problem. So it's all the print will come, and A from, so it will take A to B, transfer this from, so I name the peg to a string A, B, C. So this is source and B is intermediate. So in fact what he said, the top one you should take this and put on here. Okay, anyway, this is a solution. You just run it, you have the code, you can just see. Okay, so this is how you solve recursively. I will give one more example after some time. It turns out I will ask you to do it at home. How many steps are required to solve Tower of Honey problem for n disks? So think about it. It turns out the number rises exponentially, and there is a story that in Banaras there is a saint somewhere sitting there, and his task is there are 64 disks, and he has to transfer it here or here, and once that is done, the whole world will end. Okay, so how long will it take to transfer 64? You should figure it out. Okay, it's a huge number. So, but recursion is not efficient because it goes down, goes up. Right? You have to go down, then start coming up. So normally we avoid recursion for physics, but some problems you have to do using recursion. In fact, all the fractal stuff, if you want to print them, you have to use recursion. Okay, Tower of Hanoi, if you want to write sequential code, is not easy. In fact, I don't know the solution. There may be one, but I don't know how to solve it using iteration.